Welcome to Lesson 5, Trends in Electronegativity. Our lesson objectives describe the trend in electronegativity across a period and down a group and explain why these trends exist. So what is electronegativity? This is the measure of the attraction for electrons, and it actually means the electrons in neighboring atoms. So the attraction to pull in electrons into an existing atom. And the values are located on table S, right next to first ionization energy. The scale for electronegativity goes from 0 to 4, 4 being the highest, and fluorine is the highest value. It's the most electronegative element that we have. So the closer an atom is to fluorine on the periodic table, the higher the electronegativity, or measure of attraction for electrons. Looking at the trends in electronegativity, they're going to be exactly the same as ionization energy, because if you have a strong attraction for electrons, it also means that it's going to be harder to remove an electron from that atom. So going across a period, we're going to see a general increase in electronegativity. Why? Because as we go across a period, there is more proton pull, or more nuclear charge to attract electrons into the atom. So as we can see here, going across period 3, from aluminum to chlorine, here's aluminum, here is chlorine, and we see that there is more proton pull, a greater nuclear charge for chlorine versus aluminum, and therefore has a greater attraction not only for its own electrons, but to pull in electrons into the atom from neighboring atoms. As we go down a group, again the same as ionization energy, we're going to see a decrease in the electronegativity. Why? Because as we go down a group, the atomic radius gets larger due to more shells, and there's less nuclear pull to attract electrons into the valence shell. So as we can see here, for a small atom at the top of the group compared to a larger atom at the bottom of the group, we see there's a greater nuclear pull being felt with the smaller atom, and so therefore a greater ability to attract electrons into the atom, into the valence shell, versus the larger atom. So here's an example. What is the trend in electronegativity going across a period? When we go across a period, we're going to see an increase in electronegativity. Why does that trend occur? Due to the increased nuclear or proton pull. So we can use table S to our advantage, just like we did in our previous trends. And so if we want to see a trend going across a period, I could pick an element on the left and an element on the right in a period, look up the values, in this case 0.9 over here, and then chlorine is 3.2, so we see it's going from 0.9 to 3.2. So the trend is increasing. So again, there's no need to memorize the trends. We can just look up the values on table S. So let's check your understanding. Can you describe the trend in electronegativity across a period and down a group? And can you explain why these trends exist? So here's a summary of all the trends that we've looked at in this unit. Metallic character, how much character you have that's like a metal. So things like luster, etc. And so as we go across a period, we're going to see a decrease in metallic character because we're going from metals to nonmetals. And going down a group, we're going to see an increase in metallic character. For atomic radius, we see a decrease going across a period due to the increased proton pull, pulling the electrons in. And we see an increase going down a group due to more electron shells. And then for ionization energy and electronegativity, it's the same trend. An increase going across a period due to more proton pull, and a decrease going down the group due to more electron shells. So at this point, you should be able to describe the trend in electronegativity going across a period and down a group, and explain why these trends exist.